In this part, we will continue conducting hydrologic modeling using the HEC HMS program. And after we finished entering all data and parameters for the 14 subbasins in the study area basin in the previous parts, we will continue the implementation using the HEC HMS program. So we go to the outlet 1, and in it we go to the options menu, and in it we can enter the observed values, but we don't have observed values in this outlet, and it is optional, so we leave it as it is. Then we go to WT, or water treatment, which is a junction. Also, we don't have observed values in this outlet, and it is optional, so we leave it as it is. Then we go to the junctions. As we see, also we don't have observed values in these junctions, and they are optional, so we leave them as they are. Then we go to the first reach, R510. Then in the reach menu, we specify the options. And in the lose gain method, either we choose constant, and in this case we need the flow rate in meter cube per second, but we don't have this value. So for lose over gain method, we choose percolation. Then we go to the routing menu, and in it the values of the length and the slope exist, and in Manning's N we type 0.1. To enter the value of the index flow in meter cube per second, we read the following explanation in the Word file titled the index method. The index method. The index method. The index method is used in conjunction with the physical properties of the channel and the previously mentioned space-time interval selection. The selected index method and specified parameter will be used by the program to describe the routing reach in both space and time. Appropriate reference flow and celerities are depend upon the physical properties of the channel as well as the event S in equation. Experience has shown that the reference flow or celerity based upon average value of the hydrograph in equation, i.e. midway between the base flow and the peak flow, is in general the most suitable choice. Reference flow or celerities based on peak value tend to numerically accelerate the wave much more than would occur in nature, while the converse is true if the low reference flow or celerity is used. Pons 1983. So the experience has shown that a reference flow or celerity based upon average values of the hydrograph in equation, i.e. midway between the base flow and the peak flow. To do so, we go to the Excel file titled Observed Data for SWAT Cup. And in it we have the actual discharge values at the Dolokan Dam, and for the index flow we choose the midway between the base flow and the peak flow. So we find the minimum discharge for these values of discharges. And we find the maximum discharge for them. Then we find the average value between the minimum discharge and the maximum discharge, as we see. So the index flow in meter cube per second equal 311.9. Then in the shape we choose trapezoid. Then in the bottom width we type 2, and in the side slope we type 1. Then we go to the lose over gain menu, and in it we need the rate in meter cube per second per 1000 meter square, which is chosen from the following table. In HEG-HMS, transmission loss data are entered under loss gain method in the reach tab for each routing reach. Although measured percolation rate have been found to be highly variable, Table 772 provides some guide for their selection. If using the 8-point cross-section option or a stage discharge function as a part of the routing input, the elevation of the channel invert should be correspond to the lowest level used in 8-point cross-section or a stage discharge function for that routing reach. Table 7.2 Percolation rate for various channel bed material from SCS National Engineering Handbook Section 4 Chapter 19 Transmission Loss by L.J. Lane. In this table we have these values according to bed material, transmission loss method, and percolation rate in inch per hour or cubic foot per second over acre. So we need to transform these values of percolation rate to the meter cube per second per 1000 meter square. To do so, we go to the Word file titled conversion, and in it we can make the conversion as we see. And here in the table we have the bed material that we have in the study area are between the sand and the gravel mixture with the low silt clay content and sand and the gravel mixture with the high silt clay content. So for the percolation rate we choose 1 inch per hour or a cubic feet per second per acre. So we need to convert this value to the meter cube per second per 1000 meters square according to this relationship. To do so, we use the calculator as we see. Then the value becomes 0.007 meter cube per second per 1000 meters square. So in the rate we type 0.007 and this value is used for the discharge correction. Then we go to the options menu and in it we can enter the observed values, but we don't have observed values in this reach and it is optional, so we leave it as it is. By that we have finished inputting parameters for the first reach and we will continue implementation in the next parts.